Hi, in this set we have A, B, C, D, E and F are 6 police stations in an area. These are the police stations. This is the diagram how they are located. And they are connected by streets as shown in this figure. Now 4 teams 1, 2, 3 and 4, they patrol these streets. Patrolling is basically they watch out, they keep moving around on these streets in terms of to keep them safe. So they patrol these streets continuously between 9 hours and 12 hours each day. Okay, so from 9 till 12, that means for 4 hours they are patrolling these cities. The teams need 30 minutes to cross a street connecting one police station to another. All 4 teams start from station A at 9 hours and must return to station A at 12. They can also pass via station A at any point on their journeys. Okay, so they're basically passing through these cities, and to pass through one street it takes them 30 minutes, right? Fine. And there is no waiting time at any of these points. So waiting time will be assumed to be 0 since it's not mentioned so far. And these are the points given as to at what time which team is at which point, which station as such. Okay, so let's make a table out of it, table for it, as in every half an hour which team is at which particular station, right? So all of them at 9 am start from A and all of them at 12 noon have to reach at A. Fine. And after every half an hour they will be at a police station. It takes them half an hour to cross any street, right? To cross any street it takes them half an hour. So every half an hour they must be at certain police station, and we will figure out at which police station each team is. Cool. So let's see. None of the streets has more than one team traveling through it in any direction at any point in time. Okay. So if a team is going from F to A, from A to, let's say, C, at 9 am a team is here and it goes at 9:30 to C, only one team can go on this street, right? That is what is given. In any particular direction or on any particular street, none of the streets has more than one team traveling along it in any direction. So if a team is going from A to C, no other team can go from A to C and no other team can go from C to A as well. Fine. Next, teams 2 and 3 are the only ones in station E and D respectively at 10 hours. Okay. So teams 2 and 3 at 10 am or 10 hours, team 2 and 3 are at E and D respectively. Then you have teams 1 and 3 are the only ones in station E at 10:30. So at 10:30, 1 and 3 are the only ones at E. Cool. Then you have teams 1 and 4 are the only ones in station B and E at 11:30. So at 11:30, 1 and 4 are the only ones at B and E respectively. Then team 1 and 4 are the only ones that patrol the streets connecting A and E. So the street connecting A and E can only be patrolled by 1 or 4. No one else, no other team can patrol this street. Fine. And team 4 never passes through stations B, D, F. So team 4 will not go to station D, not go to F and not go to B. So that means team 4 will either go to station C or to station E. These are the only 2 stations team 4 can pass through. Okay? Fine. So we'll keep all these points in mind and let's start figuring out who is where. Okay? Now for team 4, we know team 4 can go to only C or E, only these 2 stations. So from A, they will either go to C or they will go to E. Okay? Now, if let's say they go to C, once they reach C at 9:30, where will this team go? Well, it cannot go to D. So the only position will be A. Even if the team goes to E at 9:30, after E, where will it go? It cannot go to F, it cannot go to D. So it will have to come back to A. So it will anyways again come back to A. Right? Fine. After A, it can again either go to C or E only, no other possibilities. And after C and E, they will again have to come back to A only, no other possibility. So for 4, you'll have A, CE, A, CE, A, E and A. These are the only, this is the only possible case, and it will be C or E in these two positions. We'll figure it out as we complete the table. Fine. Sure. Now for team 2 starts from A and at 10 AM it goes to E. So it has to go to one more station and then go to E. Okay. How is it possible to go to E via just one station? So that is only possible when you go to E via F. Going to E via just one station is only possible when you go via F. So this has to be F. So team 2 goes from A to F at 9:30, from 9 to 9:30, and from 9:30 to 10 it goes from F to E. Fine. Cool. Next is team 1 goes from A to E via 2 stations. Okay. So how is it possible to go to E via 2 stations? Let's see. A starts from A to F. Initially, since it's given that no two teams travel on the same street, it means initially the 4 teams that start, one will go towards F, one will go towards B, one will go towards C and one will go towards E, right? So we know team 2 goes towards F, team 4 will go towards C or E. So one team has to go towards B and other team has to go towards C or E. So let's see. Is it possible that team 1 goes to B and then comes back to A and from there it goes to E? That's possible. That's completely possible. Is it possible for team 3 to go to B? Team 3, if it goes to B, then can it reach D? No, it cannot reach D after that. If it goes to B, it cannot directly go to D because it is not connected. So the only possible team which can go to station B at 9:30 is team 1, right? And now once this team 1 reaches B, here, where else can it go? After B, the only station it can go to is A. So it goes to A at 10 AM, right? Fine. So at the starting, from A we knew all the 4 teams will go in 4 different directions. So 2 of them go in the direction of BF. So 2 of them will go in the direction of C and E. Now we know the team 1 and 4 are the only teams that patrol stations A and E. So between A and E only 1 and 4 can go. So 3 cannot go between A and E. So from A, 3 cannot go to E, so this must be C, and if this is C, this must be then E. Okay? Cool. Now look at team 1. Team 1 goes from A to B, then to A, then E, and from then E it has to go to E from B. From E it has to go to B via just one station. How is that possible? That's possible only when it goes through A, right? Fine. So you see, from 10:30 to 11, team 1 is patrolling between A and E. So from 10:30 to 11, team 4 cannot patrol between A and E. So this cannot be E, this must be C in that case. Okay? Fine. And now from looking at team 3 has to go from E to A via 2 stations. From E to A via 2 stations. How is it possible to go from E to A via 2 stations? Or let's look at it in a slightly different way. As we saw initially, from A all the 4 teams will go in different directions, and same will happen from 11:30 to 12. All of them have to come to A, but all of them will come from a different station, as no street can be patrolled by more than one team. So from B to A, at the end, from B to A we have team 1 coming, and from E to A we have team 4 coming. Okay? So one of these teams will come from F and the other will come from C. Fine. So one of these teams, T2 or T3, will go to A via C or via F. Let's see which one will be. Looking at team 2 is at E at 10 a.m. From E, it can either go to A, F or D. It cannot go to A because the street AE is patrolled only by 1 and 4, so it cannot be A. Right. Can it be D? See, the street DE is being patrolled by team 3 from 10 to 10:30, so it cannot be E as well. So, sorry, D, it cannot be D as well. Right? So from E it cannot go to A, it cannot go to D, so the only city or station it can go to is F. So it goes to F from here. Fine? Good. Now, if at 10:30 team 2 is at F, can it go to A via C now in via 2 stations? From F, how can it go to city C via just one other station? That is not possible. So team 2 cannot go via C to A. So it has to go to A via F. Okay. So if this cannot be F, this must be C then. Okay. So looking at team 3, from E it has to go to C. So it will have to go via D. So this becomes D. And for team 2, it has to go from F, one more station, and again F. So it has to come back to F via one station. So that one station can be either A. So from F it goes to A and then back to F. Or from F it can go to E and then back to F. Let's see if these two are possible. So between F and A, no one else is patrolling. Between F and E, no one else is patrolling. So both of these are possible, F to A and F to E. And here between A to F no one else is patrolling, and between E to F is also no one else is patrolling. So team 2 can go to either station A or E at 11 am. Right? So this completes the whole table as to which team is patrolling between which 2 stations between the times given. Let us look at the questions now. First question is, which one among the following stations is visited the largest number of times? The options are C, D, E and F. So let's calculate. C, D, E, F. Let's look at how many times is station C patrolled. So here we have 0, 1, 0, 1, 0, 1. So 1, 2, 3. A total of 3 times. Let's look at D. D is getting patrolled 0, 0, once here, twice, 2 times. Let's look at E. E is getting patrolled 1, 2, 3, 4. This may be more than 4 or not. And one more here. So for definitely 1, 2, 3, 4, 5 is definite. It can be 6 or not. So E can be either 5 or 6 times. Okay. Next is F. F is once, twice, thrice. 3 times is F. Okay. So even if we don't know exactly how many times is station E patrolled, but still it is patrolled the maximum number of times. So option C, E is the right answer here. Next question, how many times do the teams pass through station B in a day? Okay. So how many times do the teams pass through station B? That's what we have to figure out. So through B, the teams are passing once here and once here. So a total of 2 times. So the answer is 2. Okay. Next question, which team patrols the street connecting D and E at 10:15? Okay, so D and E at 10:15. 10:15 is between 10 to 10:30. So who is patrolling between D and E? Between D and E, team 3 is patrolling. Hence option A is the right answer. Next question, how many times does team 4 pass through E in a day? So team 4 passing through E in a day is once and twice. So the answer is again 2 over here. And finally, last question, how many teams pass through station C in a day? Okay. So is team 1 passing through C? No. Is team 2 passing through C? No. Is team 3 passing through C? Yes. So this is. And is team 4 passing through C? Yes, it is. So 2 teams are passing through C. Option D will be the right answer here. Okay. So that's it for this set. Thank you.